Now, isomers are, we know it from O levels, that they only share one thing, that they have same molecular form, which basically means that they're made from the same atom. So isomers are made from the same atoms. That's all. Same atoms lo, unse aap kuch bhi bana sakte ho. There's a whole variety of things you can make from them. And those are called isomers, all of them. It's like you take the same pieces of Lego and you can make a host of different things from it. और वो सारी चीजें उन्हीं pieces से बनी हुई हैं. They are isomers, all the things that you make. Now, sometimes their structural formula is different. Like the way they are arranged, like they're attached is different. उसको हम बोलते हैं structural isomers. ठीक है? So there are structural isomers. They have different structure. मतलब उनकी bonds कैसे बनी हुई हैं वो different है. इसकी एग्जांपल है, मेरे पास एक ये चीज है और यही ऑक्सीजन अगर मैं मूव कर दूं एंड आई पुट इट बिटवीन द टू कार्बन्स, तो मेरे पास ये चीज है. इन दोनों में वही एटम्स हैं, बस उनका स्ट्रक्चर डिफरेंट हो गया है और उसकी वजह से ये एक दूसरे के आइसोमर्स बन गए. बट आई कैन ऑल्सो अरेंज देम डिफरेंटली इन स्पेस, लाइक द वे आई अरेंज देम इन 3D. If I do that differently, I call them stereoisomers. That the way they're arranged, even though the bonding is still the same, but their arrangement in space is different. So unki bonding same hai. Matlab not only is this same molecular formula, they have same structure as well, but different arrangement in space. So even though bonds are same, वो bond किस एंगल पे लगी हुई है, कहां से लगी हुई है, वो डिफरेंट हो जाता है. एंगल भी सेम होते हैं बट कहां से लगी हुई है वो डिफरेंट हो जाता है. These structural formulas come in 3 different ways. I can make chain isomers, और मैं आपको सिखाऊंगा कि क्या होते हैं वो. I can make position isomers and I can make functional group isomers. Those are 3 different ways I have. And in stereoisomers, I have 2 categories. One is called geometric, and those I call cis and trans. And the other one is optical. So we have these different ways isomers are going to present themselves. So क्या है? Structure, और उसकी 3 categories हैं: chain, position, function group. And then stereo, geometric, optical. Okay, now before we move on, just tell me, function group kya hota hai?
So the part which take parts in a reaction.
Like it doesn't have to be every single time. Like you can have other parts taking part in the reaction as well. But functional group is basically a portion of the molecule. It's a group of atoms and sometimes bonds as well, like double bond or triple bond, that determines the properties, the chemical behavior, the characteristics of any molecule. One example of these is OH. OH is going to make anything act like alcohols, or COOH, or NH2, or CONH, or CN. ये सारे अपने अपनी properties compound में add कर देते हैं. Similarly, you can have double bond, carbon carbon double bond की अपनी properties add हो जाती हैं. वो alkene की तरह behave करता है, वो होता ही alkene है. कार्बन ऑक्सीजन डबल बॉन्ड की वजह से वो कार्बोनाइल की तरह बिहेव करना शुरू कर देता है, वो डबल बॉन्ड है तो वो अपना बिहेवियर लेके आएगा. ट्रिपल बॉन्ड भी ऐसा करेगा. सो ऑल ऑफ दीज आर फंक्शनल ग्रुप्स. दे कैन बी एटम्स, दे कैन बी बॉन्ड्स. ओके, पोजीशन क्या है कि विच कार्बन इज द थिंग अटैच्ड टू. अब वो फंक्शनल ग्रुप सेम रहे लेकिन उसकी प्लेसमेंट डिफरेंट होना शुरू हो जाए तो वो पोजीशन आइसोमर्स होगा. और चेन आइसोमर क्या होगा कि लेट्स सपोज द लॉन्गेस्ट चेन वी हैव इज ऑफ 5 कार्बन, अब वो 4 की होगी है, अब वो 3 की होगी है, वो चेन आइसोमर बनता जाता है. अच्छा, so let me take some examples. The simplest example that I can think of is the butane वाली example. I have 4 carbons और भी सारे हाइड्रोजन के साथ अटैच्ड हैं. बट मैं एक काम करता हूं, मैं इसको इस हाइड्रोजन से स्विच कर देता हूं. मैं 3 की चेन बनाता हूं और एक कार्बन ब्रांच में डाल देता हूं. ये है चेन आइसोमर. क्यों? ये 4 की चेन है, ये 3 की चेन है. चेन आइसोमर बनाने का बहुत सिंपल तरीका है, आप पहले सबसे बड़ी चेन बनाओ, फिर ब्रांचेस डालना शुरू कर दो। हाँ, ये ध्यान में रखना है कि ब्रांच कभी भी लास्ट पे नहीं आ सकती। कभी भी ये नहीं हो सकता कि आपको ये लें जी 3 कार्बन है और ये चौथी चेन बन गई। ये चेन नहीं है, ये एक लॉन्ग चेन है, ये स्टेम में आ गई है, मेन पार्ट में आ गई है। सो इफ आई वर टू नेम दीज, मेरे पास ये है ब्यूट एन और ये है prop ane, लेकिन this propane has a branch. This will be called methyl propane. Now notice कि methyl is on the second carbon, but because इसका कोई isomer और exist नहीं करता, मैं इसको ऐसे ही छोड़ दूंगा. But let me try to make isomers of hexene C6H12. Let's try. Let's make chain isomers. Chain isomer का क्या तरीका है? You make the first chain of 6 carbons. ठीक है, अब कहीं पे डबल बॉन्ड डालनी है, मैं फर्स्ट पे डाल देता हूं, सही है। अब बाकी इसके हाइड्रोजन फिल कर लेंगे, आई डोंट वांट टू पुट दैट देयर। अच्छा, दूसरी ऑप्शन क्या है कि मैं यही लूं, चेन वही रखूं, बट प्लेसमेंट ऑफ डबल बॉन्ड चेंज कर दूं। दिस इज अ पोजिशन आइसोमर। मैं एक दफा और करने की ट्राई करता हूं। आई कीप द 6 कार्बन चेन, बट मैं डबल बॉन्ड की प्लेसमेंट चेंज कर देता हूं। Over here, this is on the first carbon, this is on the second carbon, this is on the third carbon. क्या मैं एक और दफा कर सकता हूं? Let me try it. If I try this here, कि मैं ये double bond को यहां से move करके इधर लेके आता हूं, so now I will start counting from here. और ये वापस ये और ये isomers नहीं रहे, ये same है. Because you always pick the isomers name that gives you smallest number overall. So this is not an isomer, this is identical. But this one is isomer. So इसका नाम होगा hex 1-ene, hex 2-ene and hex 3-ene. फर्क क्या है? They are all position isomers. उनकी हर चीज सेम है, बट पोजिशन चेंज हो गई है। अच्छा, अब मैं चेन आइसोमर कैसे बनाऊंगा? लेट्स से आई टेक हेक्स 1-ene, मैं इसके चेन आइसोमर बनाने लगूं। तो चेन आइसोमर का मतलब होता है कि अभी मेरे पास 6 की चेन है, मैं 5 की चेन बनाऊंगा, और अब ये 5 चेन वाला बन गया, और एक मेरे पास ब्रांच में आएगा। अब वो ब्रांच में एंड पे नहीं डाल सकता, मैं यहां नहीं डाल सकता या यहां नहीं डाल सकता, इट हैज टू कम इन द मिडल, और मिडल में मेरे पास 3 पोजीशन है, सही है। तो आई कैन पुट इट, तो मेरे पास 3 पोजीशन है, तो मैं तीनों की कॉपीज कर लेता हूं। ओके, वन ऑप्शन इज कि वो यहां पे आ जाए, वन ऑप्शन इज वो यहां आ जाए, और थर्ड ऑप्शन इज कि वो यहां आ जाए। सो नोटिस द चेन इज द सेम, ये तीनों इनके चेन आइसोमर्स हैं, लेकिन आपस में ये पोजीशन आइसोमर्स हैं। सो मैं इसको नेम करने की कोशिश करता हूं। दिस इज हेक्स 1-ene, ऑफ कोर्स, सॉरी इट्स नॉट हेक्स, it's pent. So pent 1-ene, but it has a branch methyl on the second carbon. So ये second carbon वाला है, ये third carbon second, और ये देखें अब, this is 2-methyl pentene, this is 3-methyl pentene, this is 4-methyl pentene. Notice that the name is still the same except for this position. That's why they're position isomers. And इसमें और इसमें, बल्कि इनफैक्ट इसमें और इसमें चेन चेंज हो गई है, दैट्स व्हाई देयर आर चेन आइसोमर्स। मैं एक और चेन आइसोमर बना सकता हूं, मैं 4 की चेन बना लेता हूं, 1 2 3 4, डबल बॉन्ड यहीं डाल देता हूं, और बाकी 2 जो है वो ब्रांच में डाल दूंगा। बस मैं यहां पे और यहां पे नहीं डाल सकता ब्रांच, तो यहां पे डाल देता हूं, सॉरी यहां तो नहीं हो सकती, इधर और एक इधर, या मैं एक और काम करता हूं, मैं इधर और इधर ब्रांच डाल देता हूं। So do you notice that they're both possible? Chain isomers चल रहे हैं। So position and chain isomers are pretty straightforward to do. कोई एक chain isomer बनाए और उसमें placement change करना शुरू कर दें, branch की position isomer बनना शुरू कर देंगे। Functional group isomerism is slightly different from this. यहाँ पे इनका functional group isomer नहीं exist कर सकता because they are just hydrocarbons. But I give you an example of OH. OH is pretty straightforward to do. Let's suppose मैं एथेनोइक एसिड की एग्जांपल लेता हूं, प्रोपेनोइक एसिड की एग्जांपल ले लेता हूं. So this is propanoic acid. And if I want to make functional group isomers, तो मैं एक काम करूंगा, मैं इसको यहां पे इनके मिडिल में ले आता हूं. आई एम जस्ट स्विचिंग देम अप. सो अब ये मिडिल में आ गया है और ये इधर आ गया. So this is a completely different thing. Because this is no longer propanoic acid, this is actually a ketone because it has this thing in there. So I'll call it propanone with this alcohol group there. So it is 1-hydroxy propanone. In fact, I don't need to mention one. Usually हम 1 नहीं लिखते नाम के अंदर जब भी हमें 1 मिलता है. तो this is hydroxypropanone. अच्छा, मैं एक और काम कर सकता हूं, मैं इस ऑक्सीजन को यहां पे ले आता हूं. So now I will have oxygen here and this. Now this is no longer a ketone. It is an ester because this is an ester. This part is methyl, this part is ethanoate. So methyl ethanoate. So do you see that functional group isomers are easy to make? You just look at the functional group and see how many variations you can have there. मैंने इस पोर्शन को अलग किया, मैंने इस पोर्शन को अलग किया, मैंने इस पोर्शन को अलग किया. मैं एक और भी बना सकता हूं. मैं एक काम करता हूं, मैं सिर्फ इतने से पोर्शन को अलग करता हूं. So मैं ये करता हूं. Look at what I did. I moved this oxygen here, or everything else remained the same there. And now what do I have? I have something that is an ether as well as an aldehyde. They will not ask you to name ethers, by the way. बहुत ज्यादा ethers के नाम नहीं आते हैं, ठीक है? But मैं आपको वैसे बता देता हूं. This one is called meth oxy. Meth because of one carbon here and oxy because of the oxygen here. And this part is ethanol. Methoxy ethanol. Al because of this thing, aldehyde part. Eth because of 2 carbons here. Oxy because of this oxygen. And meth because of this carbon. This is a tough name. They will not ask you to name it. But do you notice that all 4 of these, they are functional group isomers?
So it doesn't matter that whatever new molecule will come up with, as long as the structural form, the molecular formula is same.
Yeah, they're all isomers, yes. Okay, I'm asking you to make a few isomers of C5H10, and I want you to make position isomers only. Here are some possibilities. If I want to make just the position isomers, I will first draw the chain of 5. And how many options do I have? I can put the double bond here or here, and those are only 2 options. Because अगर मैं यहाँ पे करूँगा ना, तो ये इधर से counting start कर देगा. So I will just make copies of this. So ये एक और copy होगी, and one is here, one is here. ये मेरे position isomers हैं. Okay, now make chain isomers. Chain isomer का तरीका क्या है कि अभी आपने 5 की chain बनाई है, अब 4 की chain बनाओ. Pick any one of them, उसकी chain तोड़ दो, छोटी कर दो, फिर दोबारा 3 की chain बना लो अगर बनती है तो. Now if I make a chain of 4 carbons, I'm picking this one. Okay, so it has double bond on the first one. So मैं second यहाँ पे लगा सकता हूँ, या मैं second यहाँ पे लगा सकता हूँ. So I have 2 isomers with, there are chain isomers and आपस में they are position isomers. अच्छा, now here's what I want you to do. Let's change this to just C10, H10 and Cl2. And now you will see that the number of isomers that you can get explodes. Because अब chlorine के 2 atoms लगाने हैं. तो इन्हीं isomers में अगर मैं chlorine यहाँ लगा देता हूँ और एक यहाँ लगा देता हूँ, एक option ये है. दूसरी option क्या है? एक को यहीं रखूँ, दूसरे को यहाँ move कर दूँ, या यहाँ move कर दूँ, या यहाँ move कर दूँ, या यहाँ move कर दूँ. सिर्फ एक position change करने से मेरे पास 5 different isomers possible हैं. और इमेजिन अगर मैं दोनों की पोजीशन चेंज करना शुरू कर दूं, मैं एक को यहां रखूं और दूसरे को मूव कराऊं, या दोनों को यहां रख दूं, मतलब इसको भी यहां लगा दूं, या अगले पे, या एक को इधर रखूं और दूसरे को तीसरे पे मूव कर दूं. सो द नंबर ऑफ आइसोमर्स दैट यू कैन मेक is insanely large, but they're all position isomers. Okay, all right, so that's how you make isomers, and that's fine. I think everybody's comfortable with it. If you're not, please tell me, I can give you some more practice problems. Function group isomer can be a little tough, so let's try one example of that. Let's say I have let me give you this thing. This is me ethyl ethanoate. Please make functional group isomers of this. That means you can break the functional group into two parts and you can move these points, either left, right, ye wo sara. Go on, do it. So as I showed you earlier, you can break it down into two parts. एक क्या है कि आप इसको रखो और ये लें, एक ये ऑप्शन हो गई है. All I did is move this and this, switch their placement. I can also do it another way, कि इसको ऐसे ही रखूं और इनकी प्लेसमेंट स्विच कर दूं, लाइक इन दोनों की प्लेसमेंट. So this one is ether and this one is alcohol. This is a tough one. They won't ask you to name it, so don't worry. अच्छा, इतना मुश्किल नहीं है वैसे. मिथॉक्सीप्रोपेनोन है. अच्छा, let's try another one. You can make this whole thing switch with this one, and that will make it butanoic acid. That's another possibility. Another option you can do is you can make this switch with this but not move this. So in that way this will become, और इसके बीच में कहीं पे आप ऑक्सीजन डाल दो. Let's say here. There you go. That is one option. Another option is a positional isomer of this.
So the second last one, what is it? Is it an aldehyde or what?
It is an aldehyde. This is methoxypropanol.
So the first part of that is an ether or no?
The whole thing is an ether as well as an aldehyde. So we don't say that this part is ether, this part is aldehyde. No, the whole thing is an ether, the whole thing is an aldehyde.
Okay, sir.
Okay, so these are different kinds of isomers and they're all structured isomers. Now let's look at stereoisomers. How are stereoisomers different? Stereoisomers में ये होता है कि आपके पास दो ऑप्शन है. First one is optical isomer. बहुत आसान है optical isomer करना. Optical isomer को करने के लिए what we do is we identify a chiral center. Chiral center क्या होता है कि it is atom joined to all different groups. Acha, I'll go a little beyond AS when trying to explain optical. The simplest kind of optical isomer that you are already familiar with is carbon. Chiral carbon में क्या होता है? आपके पास कार्बन है जिसके साथ चार डिफरेंट चीजें अटैच्ड हैं. So A, B, C, D. This is like our hands. That's the simplest way of looking at it. कि हमारे हाथ identical हैं एक दूसरे के, but they will not overlap with one another. Let's suppose if you had both your hands out and they were palms up, and if you try to cover one with another, आपके thumbs अभी भी sides पे होंगे. It is only when the palms are both facing out or both facing in that you're able to overlap your hands. But other than that, they don't cover each other. They are mirror images of each other. Mirror images are laterally inverted. So optical isomers are laterally inverted or mirror images. Or another word that we have for them is they are enantiomers of each other. They all mean the same thing कि वो एक दूसरे के mirror images हैं. How do you make them? You first identify an optical isomer. अब optical isomer में क्या जरूरी है? If you have carbon, तो 4 different groups होने चाहिए. Nitrogen है, 4 भी हो सकते हैं, 3 भी हो सकते हैं. ठीक है? But usually we look at nitrogen with 4 जो हम देखते हैं. कई दफा हम 3 भी देख लेते हैं. Similarly, sometimes we also get chiral centers of metals. वो मैं अभी आपको कुछ examples दूंगा. Now, how do you make the mirror image? Simply draw a mirror. Okay. And now copy this one. बस आपने करना क्या है कि अगर ये dotted line right side पे है तो अब आपने उसे left side पे draw करना है. अगर ये right side को bend हुआ हुआ है तो अब आप left side को उसे bend कराएंगे. वो this and I should use a different symbol. Let me use E for this. कहीं carbon नहीं है ना basically. So this is showing a mirror image of one another, and we usually put a star on them to show कि ये दो isomers हैं. Number of one chiral carbon doubles possible isomers. तो इसका मतलब है कि अगर मेरे पास 2 chiral carbons होंगे तो वो 2 दफा डबल होगा, तो 4 और फिर 8. ठीक है? अगर लेट्स सपोज एक चीज के 2 आइसोमर्स हैं पहले से ही, तो अब 4 और फिर 8. लेट्स सपोज उसका एक ही एटम है और वो मेरे पास उसके कायरल सेंटर एक ही है, तो वो 2 आइसोमर्स हैं उसके ऑप्टिकल वाले. हाँ, बाकी आइसोमर्स हो सकते हैं बट ऑप्टिकल वाले ही है. अगर किसी कंपाउंड में 4 ऑप्टिकल आइसोमर हैं तो उसके 16 ऑप्टिकल आइसोमर्स बनेंगे क्योंकि 4 कायरल सेंटर्स हैं. कायरल सेंटर में डबल बॉन्ड नहीं हो सकती. ठीक है? दैट इज इंपॉर्टेंट. सो चेन में तो आइडेंटिफाई करना कोई मुश्किल ही नहीं है. फॉर एग्जाम्पल अगर मैं आपसे कहता हूं कि मेरे पास ये हैं, तो मुझे बताएं कायरल सेंटर कहां पे. सो लेट्स सी. आपने इंडिविजुअल कार्बन्स को देखना. लेट मी लुक एट दिस कार्बन. इस कार्बन के साथ 1 2 3 हाइड्रोजन इन्वॉल्व है, ये कायरल नहीं हो सकता. इस कार्बन को आपने देखना है. अच्छा, जब भी ऑप्टिकल आइसोमर को आप देखते हो या स्टेरियो आइसोमर्स को देखते हो, उनकी स्टैंडर्ड फॉर्म में देखते हो. स्टैंडर्ड फॉर्म क्या है? ये ऑप्टिकल की स्टैंडर्ड फॉर्म है. अगर आप इस कार्बन पे फोकस कर रहे हो ना, तो आप इस कार्बन को लिखोगे और ऐसे बनाओ, और अब देखो इस कार्बन के साथ एक क्लोरीन है, एक हाइड्रोजन है, एक CH3 है. नोटिस कि मैंने इस पूरे पोर्शन को CH3 बोल दिया. और एक ये पूरा है, ये क्या है? दिस इज C3H6Cl. अगेन नोटिस कि मैंने उस सब को कंबाइन कर दिया बिकॉज आई एम फोकसिंग ऑन दिस कार्बन. एंड दैट इज द वे टू आइडेंटिफाई कायरल कार्बन एंड देन ड्रॉ देम. क्या आप उसको स्टैंडर्ड फॉर्म में लेके आओ और फिर देखो कि हाँ 4 डिफरेंट ग्रुप्स हैं, डेफिनेटली कायरल कार्बन. Now let me focus on this carbon. I'll put this all in standard form again. So standard form मेरी क्या है? ये और ये. Okay. So if I look at this carbon, I have chlorine on one side, hydrogen on one side, C2H5 on one side, and on the other side, I have this whole thing, which is C2H4Cl. Notice कि मैं लिख भी opposite रहा हूं. क्यों? Because the bond is with carbon, not with anything else. So it's important to mention कि bond किसके बीच में. And yes, this is also chiral. So this thing has 4 optical isomers because इसके 2 chiral centers हैं. So 2 power 2 optical isomers क्योंकि 2 chiral centers हैं इसके पास. Okay. So everybody clear?
Yes.
Perfect. All right. I'm going to give you a compound. I want you to identify the chiral center in there. G. Where's the chiral center?
So carbon number 2 from the left.
Very good. This is the chiral center. Yes. So I'll put a star next to it. Okay.
The third carbon?
The third carbon. Do you mean this?
Yes.
Yeah, it is a chiral center. Yes. Good. Any other chiral centers?
The fourth one too?
The fourth one is this one, by the way.
From the left to the right.
Do you mean this one?
Yes.
we'll call it a second carbon, not the fourth carbon, because the function group is over here. So this is where we start the counting from. Okay. So yeah, you're right. This is a chiral center. Is everybody else on the same page? Do you all identify both of these as chiral centers?
So what about the first carbon?
Which one? This one or this one?
No, so it's from the right.
From the right. This one has a double bond. Double bond means it can't be a chiral center.
Okay, sir.
Okay. Yeah. Now let me give you another one. Okay. Let's do this.
So the carbon next to H2N from left.
Okay. Are you saying this one?
Yes, sir.
Does everybody agree that this is a chiral center? You're absolutely right. This is a chiral center. Because if I were to put it in a, like in the standard form, I'll put carbon, hydrogen, NH2, CH3, and this whole thing. Okay. So this is a chiral center. Absolutely correct. Any other chiral centers?
So next to NH.
Yes, you're right. This one is a chiral
This one,
center.
yes, sir.
And the one underneath that?
The one below it. Yes, that's also a chiral center. Good. Any other chirals? All right. So tell me, how many optical isomers will this compound have?
8.
8. Yes, because 2 power 3. Okay. Now let's identify them, but in the structural formula. So here's the structural formula. Where's the chiral center?
So second carbon from the left.
Very good. This one is the chiral center. Yes. Let's try one more. Where's the chiral center? The reason we did 2 power 3 in the previous one was that you had 3 chiral centers. Every center doubles the optical isomers. Like it creates 2 optical isomers. So 2, 4, 8. Okay, where's the chiral center here?
So the center one.
PH center.
Let's see. Do you mean this?
Yes, sir.
Let's put it in a standard form and identify if that is actually correct. So I have H here, OH here. On this side, I have this CH2OH, and on that side, I have this HOCH2. Is that actually a chiral center? What do you think? Is it?
Oh,
It's not, right? Because it's symmetric. So not a chiral center. Okay. Now, how do you do this in the structure, in the skeletal formula? Let's see. Okay. This is menthol, by the way. How many chiral centers we have? Let's see. So the way to look at a chiral center is to look at the whole structure on the left and the right. So for example, this carbon is attached to a CH3 here, and this whole thing, which has no OH, but this whole thing has an OH. So this is one different branch from this branch. Okay. And how do you know about hydrogen? Like, where's the hydrogen there? So what I usually do is that when I look at these things and I want to identify hydrogen or count them, I just basically do this. So this is going to be a W. This is 1. So I draw these chicken feet here. So once you have drawn all the chicken feet, you know where the hydrogens are. So you can clearly see that this one is a chiral center. This one is a chiral center. This one is a chiral center. And I guess that's it. Now I'm going to give you a compound. Try to draw the chiral centers. So when you oxidize this, you get this. This thing is called menthon. So go on, identify the chiral centers.
Chiral centers.
Let's see.
so there is a chiral center beneath oxygen.
I'll draw the chicken feet first. Okay, I think this is a chiral center.
Yes, sir.
This is a chiral center. And yeah, I think that's it. Okay, I'm going to give you cholesterol and I want you to identify the, oh God, it's a big compound. Okay, that's cholesterol. For ease to point out, I'm going to number these shapes. So 1, 2, 3, 4, and this is the 5. So identify if there's chiral center in 1. Is there any chiral center in 1? Do you want me to draw the chicken feet?
So there is a chiral center
Yes. Where is it?
right after
No.
OH.
So the one attached to OH is a chiral center. That's correct. Why? Because the second carbon to this is attached to this hexagon, but the second carbon to this is not attached to any hexagon. So this is a chiral center. And of course, there's the hydrogen here as well.
So there's another one, I think, also in 1.
Let's
where
see.
there's the branch sticking out.
Yeah, this one. Yes, that is a chiral center. You're right. Can this be a chiral center?
No.
No.
Why not?
Double bond.
Double bond, yeah. Okay. Can this be a chiral center? This has a hydrogen. But other than that, is it attached to 3 different groups?
So it can be.
It is. It is. Like this is a whole different carbon than this carbon. And that is a whole different carbon than this carbon. So it is a chiral center. Okay, what about this carbon? It's attached to 1 hydrogen. But other than that, do you agree that this is a chiral?
Yes.
Okay, how about this carbon?
It is.
It is a
Yes.
chiral. And how about this carbon? It is also a chiral because it's attached to a hydrogen and the rest of it is different. Of course, this is also a chiral. And let's see. This is also a chiral. And can this be a chiral?
No,
One
sir.
carbon.
Why not?
Nice.
So 2 CH3 groups.
Exactly. It's attached to 2 methyl groups. And for the rest of them, of course, they can't be chiral because if you draw the chicken feet, you will know that they have multiple, like this one is 2 hydrogens, this one is 2 hydrogen and all of that. This one is 3 hydrogens. So because of that. Okay.
So has this ever come up in exam? Cholesterol like this?
Cholesterol pe question I have, but not to identify chiral carbons.
Okay.
Okay. This is another important hormone that we use. Let's just try this one. This is a pentalon. Okay. Okay. Yeah. This is testosterone. Does anybody know why it has O and E at the end of the name?
So ketone?
Ketone part. And this is the ketone part.
What about the OH part? Is it in the name anywhere?
So this is not a systematic name. It's a common name of this thing.
Okay.
Yeah. The systematic name does have hydroxy mentioned in there.
All right, sir.
All right. Now identify the chiral carbons here. And again, I'm going to name these shapes. So go on. Tell me if there's a chiral carbon in the first one.
So there's only one.
Which one?
Uh,
This one?
The branch one, yeah.
Yeah, that is the chiral carbon. Yes. Any other chiral carbons in shape 2?
2 of them.
This one is.
So as well as the other one.
Yes. Yeah. Similarly, this one is a chiral carbon. This one is a chiral carbon. And this one is a chiral carbon. But do you notice that most of the chirals are at the boundaries where they join with the next ones? So yeah, that is usually a simple way of identifying that. We don't look at the ones that are not at the boundary or that don't have double bonds. Like we look at the ones that don't have double bonds and they are at the boundary. That's what we usually do when we are trying to identify chiral carbons.
So in the exams, you just ask the number of chiral carbons and the number of optical isomers. That's all.
Usually that
Regarding
is
to
a 1 or
this.
2 mark question that comes. Yes.
Okay.
And of course, in the organic synthesis part, they can ask you questions about what will happen if you oxidize this. Then I know that this part can be oxidized, this part can be oxidized, but not this part. So of course, something will happen here, something will happen here.
Okay, sir.
Yeah, so they do ask you questions about that. All right. See you later.